Hey guys, it's Mr. S. Catching up on some old videos that we didn't get around to posting, mostly because we are not getting very many viewers. So um, we're gonna zoom through this. I got all the chapter 6 stuff coming up, and we're just gonna go through this. Clearly, we've already taken our test and everything on this, and we're on to chapter 8. So I'm not gonna spend too much time on this, but we will go through it. So here we go. First thing we need to do, I just need to make sure that y'all remember how to find a point on a graph. So this point here is 0, because x is 0, and down 3 on my y-axis, so my y is -3. Here I have x is 1, 2, 3, 4, 5 over, and we don't go up or down any, so there's that one. On this one, x 1, 2, 3, up 2, so my point is 3, 2. Yeah, this is hopefully really easy. We've done all this before. Here's a 1, 2, 3, 4 backwards, so -4, down 2, -2. So knowing that you guys can find these points over 7, down 3, this is a good start to what we're doing. Now, a quick review on graphing. Y equals x plus 3. We know plus 3 is our y-intercept, so on the y-axis we go up to 3 and put our dot. There is a invisible or understood 1 over 1 here for our rise over run, up 1 over 1, up 1 over 1, and that also means we can go down 1, backwards 1, down 1, backwards 1. We have our line. For this one, 3x plus 1, we start here at 1, and our rise over run up 3 over 1, or we can go down 3 backwards 1. Okay, so quick review, make sure we get all this. Here's another one. X minus 3 means we go down 3, and we go up 1 over 1, or down 1 backwards 1. On these graphing ones, you're going to need to make sure you go both directions, because what's going to happen is, and here's another one, -3x plus 1. Here's the plus 1, and down 3 over 1, because the -3 means down, or we can go up 3 backwards 1 for our negative slope. But what's going to happen is we're going to have two graphs, and they are going to cross. So when I graph this purple one here, x plus 3, we graph this one a little bit earlier. That one goes like that. Y equals 2x plus 4. Here is 4, and normally we go up 1 or up 2 over 1, up 2 over 1, but we need to go down 2 backwards 1 also. So you can see my green line and my purple line, they cross right here at this point, -1, 2. Okay, this is important. This point right here is very important. So when they ask for the solution of this line, it would be -1, 2. Okay, and we'll get to that here in a second. Here's another one. 2x plus 3, here's my plus 3, so up 2 over 1. I want to go this direction also, down 2 backwards 1. -2x minus 5. Here's minus 5, down 2 over 1. I can't keep going that way. I got to go backwards to cross my other line here. Okay, this point right here, -2, -1, would be our solution for that. So that's basically, in a nutshell, what 6-1 is. These system of equations, they're going to give us two equations. And the goal is to find out, when we're graphing, where they cross. Because that point there, when I plug in x and y in both equations are true. Now, going back here, I can plug in any of these green points here and make that a true statement. And I can plug in any of these purple points here and make that a true statement. But this point right here is the only x and y combo that if I plug in x and y here, it will work. And if I plug that same x and y here, it will work. That's what we're doing here with graphing. Okay? Let me move this out of the way. A solution is where the graphs cross. Okay? If it's consistent, it does cross somewhere. If it's inconsistent, then we have parallel lines that never touch, so there's no solution. So like on this one, my solution would be 1, 1. You can kind of tell it's a little bit off, but you get the idea. Independent means you'll have two lines that cross exactly one time. If you have dependent, you'll have infinite number of solutions, because even though this looks like one line, it's actually going to be written two different ways. Okay? When I solve both of them for y, or when I plug in x and y, anything here will work. Okay, so it's actually one line directly on top of itself. Okay, so let's see. We did workbook page 73 for homework. But just make sure, and this video is pretty much done, just make sure you know that you want to be able to graph everything, and you're just looking to see where they cross, or if they're the same line, or if they never cross. This would be no solution. This one would be infinite solution, and in the red, you would put what point they cross. So that is 6-1, graphing systems of equation.